Good day to Sir Marcus and everyone who are watching. Today, my group and I, which consists of Sean Ho, Marvin Sean, Radhatun Shifa, Fadila Wong, and Abdul Aiman, will be presenting on the topic probability distribution.
For the discrete random variable, we have decided to do dice roll. We will find the probability of getting odd numbers. Moving on to continuous random variables, we chose to collect data of height for 116 from 5 students.
How did we collect our data? So for discrete random variables, we did an experiment by rolling dice for 30 times. For continuous random variables, we made a survey by creating a Google form and sharing it around to the Form 5 students.
This is the table of rolling the dice experiment that we have to take note. The numbers we want to take note from the experiment are 1, 3, and 5. As you can see in the table, we have a total of 30 trials, means we have rolled the dice for a total of 30 times. We have recorded a total of 30 odd numbers. Each trial will have different probabilities. Moving on, the formula of calculating the cumulative trial mean of getting odd numbers from the dice is the number of cumulative 1, 3, 5 obtained from the first trial, which is n, at that instant over number of trials at that instant.
Moving on to continuous random variable, based on our survey, these were the outcomes. There were a total of 116 students that have taken on our survey about the Form 5 students' height. After we're done with the survey, we arrange the height in ascending order so it's more arranged. The sum of height X are 3,524, while the sum of respondent F is 116. The sum of Fx is equals to 19,354, while the sum of respondent of Fx squared is 3,235,220. As for the mean value, the formula is Fx over x. Therefore, we take 19,354 divided with 116 and we will get 166.84 as our mean value. As for our standard deviation, the formula is square root variance. Therefore, for the variance, we will take 3,235,220 divided with 116, then subtract with mean value, which is 166.84 squared. After having the variance value, we will square root the variance value and we will get 7.36 for the standard deviation.
We chose 0.43 as our probability for our graph because it is the most consistent in a table we have recorded.
So the quantitative for the DRV, which is the mean and the standard deviation. The mean is equal to NP, the number of trials, 10 multiplied with the probability of success, 0.43. So 10 multiplied with 0.43 will give us 4.3, which is the mean. Meanwhile, for variance, which is equal to NPQ, number of trials multiplied with the probability of success, 0.43, and the probability of not getting success, 1 minus 0.43, which is equal to 0.57. So the variance, 10 multiplied with 0.43 and multiplied with 0.57, which gives us the variance 2.451. So since we need to find the standard deviation, so square root of variance will give us 1.566. So after deciding the number of trials would be 10 and the success probability of 0.43, this is our distribution, our binomial distribution graph would look like. So as we can see from this graph, the highest point would be at the fourth trial with the probability of 0.246. And also the graph is not symmetrical as it is skewed to the right. And besides that, as we can see that from 0 to 4, the probability is increasing, and after that, the probability decreased at 5 and then it reached 0 at the 10 trials.
Next, this is our graph. On the horizontal line, it is the height in centimeters. So this app is called Desmos. Thanks to Sir Marcus for introducing this to us. As we can see, the value in the mid and max is infinity, which means the probability under the graph is equal to 1.
So, we came up with 3 possible ranges of probability. Firstly, in this set of 116 students, we want to find the probability of students with height less than 175 centimeters. According to the Desmos app, the probability of students with height less than 175 centimeters is 0.8662, which is 86.62% of the 116 students. The reason why we chose probability height less than 175 centimeters is because we observed that most of the Form 5 students lies in this height average. Next, we have chosen the probability height more than 160 centimeters. Based on the Desmos app, the probability of students with height more than 160 centimeters is 0.8236, which is 82.36% of the 116 students. Last but not least, we combine both 175 centimeters and 160 centimeters as one. So, we want to find the probability of student with height more than 160 centimeters but less than 175 centimeters. Based on the app, the probability of student with height more than 160 centimeters but less than 175 centimeters is 0.6899, which is 68.99% of the 116 students. Now, I am going to explain on how to convert the probability for each of the ranges to actual number of students based on the ranges that we have set. For example, for probability height less than 175 centimeters, the percentage is 86.62%. When we want to convert it to number of students, we have to divide it with 100, so that we'll get the probability, which is 0.8662. From there, multiply 0.8662 with 116 students and we'll get 100 students in total that has height less than 175 centimeters. So, we have to apply the same formula for both of the other ranges and you will get the number of students for both of them. So in conclusion, the formula is percentage over 100 multiply with total number of students, which is 116 based on our survey.
In conclusion, we can tell the graph is skewed to the right and the mean is 0.43. But when we decrease the mean value to 0.23, for example, the graph will skew to the right even more.
So the add-on questions, why is the distribution of the graph is skewed to the right? Well, it is because our probability of getting the success P is less than 0.5. If the value of P is equal to 0.5, that will give us more symmetric graph. That means the highest point will be at the middle. And if the value of P is more than 0.5, that will give the distribution of the graph is skewed to the left, which will be the opposite of our graph.
Referring to our graph, we can see that it is narrowly spread. We determine that by the value of standard deviation that we obtained earlier. The importance of the standard deviation value is it tells us how spread out our data distribution graph. Basically, the greater the standard deviation, the wider the spread out of the graph. In this case, our range of height is from 150 cm to 183 cm. After doing few calculations, we get the value of standard deviation of 7.36 cm.
That is all from us. Thank you for watching.